It all started with this image. Spotted in 2023 on an ephemeral forum of Stable Diffusion creations, well, it sparked something. Even though AI was exploding in popularity, I'd yet to find anything that really interested me. From the writing side, it mostly felt like a way to generate more slop for the internet, something I was at the time employed to fight against, and on the image side, I primarily only knew about the specter of deepfakes and that one image that won a competition and angered traditional digital artists. But this was different. It was not an image masquerading as effort or even human. Instead, it was something that I could recreate. I've always dreamed, as someone who never put the time into learning how to illustrate, of being able to bring an image conjured in my mind into the real world, and this seemed like a way to finally do it. I dove in headfirst, quickly learning, as with all things, that high-level Stable Diffusion and AI art involve much more than just typing some words into a text box. Let's start at the beginning. Stable Diffusion is a deep learning text-to-image model based on diffusion techniques. In practice, this means that a user is able to turn random pixels into a cohesive image. While many people have been exposed to AI art from tools like Midjourney or DALL-E, the AI camera found on newer Google Pixel devices, a feature which makes high ISO low-light images look better, is also a demonstration of diffusion-based denoising technology. Stable Diffusion, unlike most other AI denoising tools, runs locally and is open source. By using positive and negative text prompts, along with a handful of tuning settings, a Stable Diffusion user has complete artistic control over the images they generate. To demonstrate, let's start with the simple prompt of a dog. Now, how about a happier dog? Or specifically a corgi? Or corgi giraffe, because the idea of short corgi legs on a giraffe sounds fun. By keeping all settings the same and building on our positive prompt, we can start to see the power of Stable Diffusion. With this image, there are two big things I dislike. It looks like a wrinkled Polaroid, and the giraffe corgi looks like it's yelling. This is where the negative prompt can be helpful. Trying the negative prompt of yelling closes the mouth and leaves the image with wrinkles. Swapping yelling for wrinkles gets rid of the wrinkles, and intuitively combining the two will solve both problems, which it does, but I don't like the resulting image. How about just the negative prompt of tongue rather than, being abstract with yelling? Now we have a better face, bring back in wrinkles, and with just a little trial and error, we get a decent-looking giraffe corgi. That being said, more simplistic prompts leave a lot up to chance. More complex prompts allow Stable Diffusion users to truly dial in the image they wish to create. For our demonstration of variables, we will use the more complicated positive prompt. High detail color photo of 22-year-old girl 1 Livia, photorealistic, with a distant crowd of people in background, at night, at a fair in the dark, overalls, auburn hair, smiling, colorful neon lights, holding brown paper coffee cup, hazel eyes, high detail hair, subtle freckles, skin imperfections, detailed face, intricate, masterpiece, highest quality. And the negative prompt of watermark, low quality, medium quality, blurry, censored, wrinkles, deformed, mutated, extra fingers, mutated hands, bad proportions, oversaturated. By utilizing a control prompt that provides a human face, we can easily identify the results of tweaking each of the main settings used in SDXL. Let's start with the model variable. A model in this instance is not this girl. Instead, a model is a collective AI framework trained on millions of tagged images for the purpose of image generation, though I will use this specific image as the baseline for many of our comparisons. Stable Diffusion users can create their own models, or use ones created by members of the community found on websites like Hugging Face or Civet AI to efficiently create uniquely stylized images. If we look at a comparison breakdown of these images, we can see that many models only have subtle differences in their construction, but other models can create more artistic versions, more elfish versions, or anime-styled versions from the same prompt and variables. Some models will require the user to adjust more nuanced settings like face restoration to make their images look better, but those tweaks can make other models look worse. Then we have CFG, or Classifier-Free Guidance Scale, which determines how closely the image generation model follows the text prompt. Higher CFG values result in images that strictly follow the prompt, but often feel crispy, whereas lower CFG values generally result in images that feel more cohesive by treating the prompt as a guideline rather than a strict command. Manipulation of model and CFG provides specific user control over how the image will look, but seed is effectively random. The seed determines the initial random noise used for an image, and while it is essentially impossible to plan a seed ahead of time, testing data, shown later, demonstrates the consistent impact of seed on qualitative appeal. Our next variable to look at is sampler. Comparing samplers side by side illuminates the nuanced differences between each image. Sampler choice often comes down to aesthetics, though there is an efficiency component to consider, with some samplers rendering twice as fast as others, but I primarily focused on the qualitative testing of preference. And finally, steps. In the seed comparison, I showed the unrendered noise of an image with 1 step processed compared to 100 steps, but this is the whole visual example of an image being built, step by step. Each step continues the fundamental process of denoising the image toward the prompt provided. To study the effects of these variables, we're going to need a lot of images to compare. You can interact with Stable Diffusion directly through command prompt, but it helps to use a GUI like Automatic 1111. These screenshots look busy, but if we break it down, the top section here is where the positive and negative prompts go, right next to the big generate button. The next section has easy-to-use controls for the aforementioned variables, resolution control, and a few post-processing features like high-res fix and refiner switching. In generating a large sample size of images, we will be controlling model, CFG, and sampler with an XYZ plot script so the images can generate without much babysitting. Seed is processed iteratively due to a batch size of 3. In the XYZ plot, you can see that our X variable has been set to checkpoint, the proper Stable Diffusion term for model. Our Y is set to control CFG, and our Z variable to control sampler. Altogether, we have 3 seeds, 4 CFGs, 8 samplers, and 18 models to test with, resulting in 1,728 total images. With enough images, we can examine how each variable contributes to Stable Diffusion as a tool. Testing should create a large data set that controls for specific artistic preference, allowing us to perform qualitative analysis on responses to the dataset rather than each image. First, we need to deal with the mess of images produced by a multi-day Stable Diffusion run. While it may seem like those images are completely random, their file numbers are created sequentially, starting again from 0 on each new day. To properly test multiple participants, I used this batch file I found on How2Geek to completely randomize the file names and therefore image order for every participant. Then, I had users go through the image set and assign each image a star rating from 1 through 5. Each participant graded images in Adobe Bridge with the exact same window spacing on the exact same monitor and using the same keyboard and general setup, though when I tested on the road, some environmental conditions were a little different. With collection done, it was then time to convert the data to a usable form, which may seem difficult with randomized file names. Thankfully, every image generated by Stable Diffusion includes generation metadata stored in PNG chunks within each PNG file. With the help of ChatGPT, I wrote a Python script to extract this identifying information into CSV files that I could then import into Google Sheets. It was a lot of data. Though, before we take a look at the data, I should explain a little bit about what is going on in this sheet. First is some data cleanup, trimming some of the values to make them more readable. Then, combining those data into different variable groupings to see if any trends emerge, as well as a combination of all 4 variables for a control value, just to make sure there are no accidental duplicates. At last, the data can be queried into a new sheet to numerically show that I, for example, preferred the sampler DPM++ 2SA Keras. I had a strong preference for lower CFGs, loved the model's Sweet Lens SDXL V10, and strangely really disliked the seed ending in 703. As for combinations, it appears I liked the combination of 2SA Keras, a CFG of 2, and the seed ending in 704, a result potentially buoyed by my strong affinity for images from the Sweet Lens model on the 704 seed. And, just to make sure, the control values are queried as well. All 1s, no duplicates. But of course, the point of this testing is to go beyond proving what I like, but instead trying to show what choices of our 4 variables were most effective in general. To do that, a similar series of calculations and queries were performed, with an extra weighting step since everyone had different quantities of 5-star ratings, to eventually get generalized results. Results which I will show in chart form rather than continuing to show screenshots of spreadsheets. Across the images graded 5 stars, a weighted 24% of them belong to the Sweet Lens model, with Formula XL and Dream Shaper Alpha XL rounding out the top 3. Sampler was a bit more of a contested race, supporting the notion that sampler choice is largely a function of personal preference, though the sampler DPM++ 3M SDE was considered notably less favorable. CFG showed a strong preference for lower values, with images generated with a CFG of 2 making up nearly half of the weighted 5-star results. And lastly, seed, which had a pretty even split between 702 and 704, leaving 703 to be amusingly disliked. If we look at some of the combinations of values, the pie chart gets a bit messy. Simplifying it to the top 5 results of sampler and model, we see exceptionally strong performances from the DPM++ 2M SDE exponential sampler when combined with Sweet Lens SDXL V10, as well as Euler A when combined with the Formula XL V10 model. If we add CFG into the mix, our top 2 look very similar, with 2M exponential Sweet Lens and Euler A formula pairing very easily with the popular CFG of 2. With this analysis in hand, Stable Diffusion can be used as a well-understood tool. Now, we prompt. One option is modification of an existing prompt, like the one we've been using. Say we want to tweak it to be an image of an older woman, just change the age. Or an image of an Asian girl, just add Asian. Or an image of a boy. Simple. To extend this idea, a brand could use Google advertising demographics to specifically tailor images to users while maintaining their brand identity. Or it can be used to make textures for 3D models. By training a diffusion model to understand what the UV of an object like a desk means, one can rapidly generate unique textures for objects. For example, this technique could be used in game development to differentiate repetitive objects, like desks, to increase immersion. But that's content for the next video. Nonetheless, with this qualitative analysis of variables, I can start with entirely new prompts. I can quickly bring fashion ideas to life, create thematic settings for use in writing or photography, or just create art for the sake of art, like these dodecatics. Many of the images shown in this video were generated using Stable Diffusion, and I believe they are tagged in such a way as to follow all international laws around AI image generation. All of the assets used in this video can be found in the video description, along with my script and the Figma board used for planning and revision. The testing images and Google Sheet used for data analysis are down there as well. I never did make the image that started this journey. Frankly, I never came close. I completely forgot about it until I was reworking this video for public release. Instead, like all great art, it served as an inspiration for discovery and experimentation. It provided that revelatory spark that leads to new genres of creativity, which is why I don't hesitate to refer to some works created by machine learning as art.